Hi guys, so today we're going to talk about how to solve radical equations, right? We know how to simplify, we've been adding, subtracting, multiplying, and dividing radical expressions, so now let's solve some radical equations. So when you solve radical equations, there's going to be two steps that you follow. It's like solving any other kind of equation, you guys, right? You isolate and you solve. So the first step in solving radical equations is to isolate the radical, okay? So you want to get the radical on one side and everything else on the other side, okay? The second step is to raise both sides to the index power, all right? So whatever the index is, whatever the root we're looking at is, you want to raise to that power. We are only concerned with principal roots, and you'll see why I wrote that as we go through these. And you also want to be sure to always, always, always check your answers when you do these types of problems. So let's get started. So here's our first example, and we're just going to go through those two steps that we talked about on the previous slide. We're going to isolate our radical. We want our radical on one side and everything else on the other side. And then we're going to raise both sides to the index power. Okay, so let's take a look here. Well, this first one's really nice. We have the square root of x equals 8. Okay, and we want to solve for x. We know this is an equation. We see an equal sign. We have to figure out what value for x is going to make that statement true, right? So we need the radical on one side, this is our first step, and everything else on the other. Well, this one's really nice. The radical is on the one side and everything else is already on the other. So this one's already all set for us. So you know I like to put the problem on the left side, my work on the right, so I can see where everything's coming from. So I already have my radical on one side of the equal sign, everything else on the other side of my equal sign, and in this case everything else is just 8. So all I need to do is raise both sides to the index power. Here my index is at invisible 2, so I'm going to square both sides, just raising it to the second power. Okay, the square root of x squared is just x. 8 squared is 64. So here my answer is 64. So now we need to check. Always check your answers when you solve radical equations, you guys. All right, so my original equation here was the square root of x equals 8. I'm plugging in 64 for x, so wherever I see an x, I'm going to put 64. Square root of 64, is that equal to 8? Well, yes, it is. And do you remember how I said on the first slide we're only concerned with principal roots? That's why I said that, okay? Because negative 8 is also a solution for the square root of 64, but we're only concerned with the principal positive root for these, okay? So for our purposes, we're just taking into consideration the principal root. So square root of 64 is 8. 8 is 8, so this does indeed check, all right? Let's look at another example. Okay, so let's look at our second example here. The cube root of x plus 6 equals 11. We want to solve for x. So remember that means we want the radical on one side, everything else on the other. So this one, we have the radical on the left side, but we also have the 6 on the left side. We need to get that over to the right, okay, before we can raise to the index power. So that's what we're going to do first. So let me draw my line. Okay. We have the cube root of x plus 6 equals 11. And it's important to just notice that that 6 is not underneath the radical, okay, you guys? That 6 is separate from the radical. So how am I going to get that 6 onto the other side? Well, I'm going to subtract it. That will get it off of the left side completely, which leaves me with the cube root of x is equal to 11 minus 6, which is 5. Okay, now I do have the radical on one side, everything else on the other. So now I can do my next step. I can raise to the index power. Here the index is 3, so I'm going to cube both sides. All right, the cube root of x cubed is just, of course, x. Remember, the power and the radical here are just going to cancel out. Right, so I'm just left with x. And then 5 cubed, what does that mean? It means 3 copies of 5 being multiplied together, right? 5 times 5 times 5. So 5 times 5 is 25. And 25 times 5 is 125, which leaves us with x equals 125. Remember, it's super duper important to always go back and check these. So let's check. So anywhere we see x, we're going to plug in 125. So we're going to say the cube root of 125 instead of the cube root of x, okay, plus 6 equals 11. The cube root of 125, we are looking for what number multiplied by itself 3 times gives us 125. We could do the prime factorization, we could simplify it, but we know from the work we just did on the right side that that is 5. You could also plug that into your calculator if you really needed to. Plus 6 equals 11. Is that true? Well, what is 5 plus 6? It's 11. 11 equals 11. That is indeed true, so that checks out. Okay, let's look at another example. Okay, so here is our third example. Here we have, excuse me, the square root of quantity 3x minus 2 equals 1. So remember, guys, we have only 2 steps for solving these. The radical on one side, everything else on the other. Well, you guys, because it's this entire quantity under the radical is already isolated on one side, right? It doesn't matter if there's more than one term underneath that radical. We just want only the radical expression to be on one side by itself, and indeed it is here, okay? So we have the radical on one side, everything else on the other. We just have a 1 on the other side. So we can just raise to the index power right away here, okay? Because the radical is already isolated. That entire quantity is underneath the radical, so the radical expression is already isolated. So we can hop right into raising to the index power. Since this is the square root, we have that invisible index of 2, so we're going to square both sides. Okay? The square root of 3x minus 2 squared is 3x minus 2. 1 squared is 1. Okay, now we're going to have to do a little bit more work to solve for x. So we're going to add 2 to both sides, of course. That cancels. 3x equals 1 plus 2 is 3. We divide by 3, both sides by 3. X equals 1. Okay, let's see if that checks out. So we've got to plug x equals 1 in for x over here. All right, so that's what we're going to do to check. So we're going to have the square root 3 times 1 minus 2, and we're going to see, does that indeed equal 1? So we have the square root of 3 times 1 is 3, minus 2 equals 1, which leaves us with the square root of, what's 3 minus 2? Well, that's 1. And the square root of 1 is indeed 1. So that checks. Okay? All right, let's look at another example. Okay, so we're just trying to get a little bit more complicated each time with you. So now let's look at one where we have 2 terms under the radical, another term on that side, set equal to something. Okay, so here we have the square root of quantity 5n plus 1 and quantity minus 2 equals 4. Okay, so remember we have 2 steps for solving radical equations. We isolate the radical on one side, we put everything else on the other side, then we raise to the index power. Do we have just the radical on the left side over here, you guys? No, okay? We have our radical expression, but we also have this minus 2. So we have to get rid of this. We have to get it over to the other side, then we can raise to the index power. So let's do that. Whoops. Let's get rid of that. So let's get started. All right, so we have the square root of quantity 5n plus 1, okay, minus 2 equals 4. Remember, we want the radical on one side, everything else on the other, so let's get rid of this 2. We cannot have something else on the same side with our radical, right? Add 2 to both sides. That leaves us with the square root of quantity 5n plus 1 equals 4 plus 2 is 6. Okay, now we have our radical expression on one side and everything else on the other. Now we can move on to our second step and raise the index power. Again, this is a square root, so we have that invisible index of 2. All right, so we're going to be squaring both sides here. So let's do that. Square the left, square the right. The square root of 5n plus 1 squared is 5n plus 1, of course. because the index and the exponent just cancel. 6 squared, that's 6 times 6, right? 2 copies of 6 being multiplied together, 36, right? We still have to solve for n, so we've got to isolate that n, so we have to do a little bit more work here. So we're going to subtract 1 from both sides. 5n equals 35. Then, of course, I'm going to have to come over to this side to finish this problem. All right, so that leaves us with 5n equals 35. Right. Let's divide by 5, both sides, to isolate the n. Boom. N equals 35 divided by 5 is 7. All right, so we've got n equals 7. We do have to go check, so I'm just going to erase some stuff so I can then check this answer. All right, so we got that n equals 7. I'm going to write that up here so I don't lose track of it. All right, so now everywhere we see an n, we're going to plug in 7, right? So the square root of 5 times 7 plus 1 minus 2 equals 4. 5 times 7 is 35, okay? 35 plus 1 is 36. So we have the square root of 36 minus 2 equals 4. Square root of 36, remember we're only concerned with the principal root, so we're just going to take the positive root. So 6 minus 2, does that equal 4? Well, yes. 6 minus 2 is 4, which leaves us with 4 equals 4, which is true. All right, so that checked out. Let's look at one more example that just gets slightly more complicated, and you're going to see why. The next example is going to show you why the check is so important. Okay, guys, so this is going to be the last example that we do together, and it's going to demonstrate exactly why checking these is so incredibly important. So the nice part about this problem is that we already have our radical isolated here on the left side, right? Our radical expression is on one side, everything else is already on the other. So we can jump right into that second step of raising to the index power. So let's do that. So we have the square root of y minus 2 equals 8 minus y. All right, so like I said, our radical is already on one side, everything else is already on the other, so let's raise to the index power. We have, this is a square root, so we have that invisible index of 2, which means we're squaring both sides. Then, of course, on the left side, the exponent and the radical are going to cancel out, so we're left with y minus 2. And on the right side, now, guys, this is important. We are squaring a quantity. So this entire quantity is we want 2 copies of it multiplied together. So 8 minus y times 8 minus y, okay? That quantity is being squared. Important, very, very important, okay? Which means we need to FOIL. So I am pretty confident in your guys' ability to FOIL, so I'm just going to jump right to it. 8 minus y times 8 minus y, that's going to leave us with y squared minus 16y plus 64. And now, you guys, we're left with a solve like we saw in the very first chapter that we did together, right? We need to get everything on one side, 0 on the other side. We need to get this whole polynomial set equal to 0 so that we can factor, use the principle of zero products, and solve. So I need to get all of this stuff onto the other side, which is exactly what I'm going to do. So I'm going to add 2 and subtract y, okay? So I'm basically adding 2 to both sides, and I'm subtracting y from both sides. And what is that going to leave me with? That's going to give me 0 on this side, y squared minus 17y plus 66 on the other. And why is that so good? Because now I can factor and use the principle of zero products to solve this. So I'm going to hop on over to the left side so I have some more room. Let's see how I can factor this. You guys, this is not a factor by grouping, right? We do not have a GCF we can pull right out. So then we count the terms. We have 1, 2, 3 terms, just a quick review, which means we're going to do the AC method. So we would do our AC, which would give us 66, and our B is equal to negative 17. So we are looking for factors of 66 that add to negative 17, and spoiler alert, they are negative 6 and negative 11. So when I do this all out, this factors as, let me get my pen back, sorry. this factors as y minus 6. We can do that lovely little trick. Y minus 11, okay, because our a is equal to 1. And we know that equals 0. So by the principle of zero products, we know that either y minus 6 has to equal 0 or y minus 11 has to equal 0. So if it was y minus 6 that equaled 0, let me erase that. I don't want to be sloppy. So if it was y minus 6 that equals 0, then y would equal 6. Okay, so there's one answer. Notice we're going to get 2 here, you guys. Well, what if it was y minus 11 that equaled 0? Then that would tell us that y would have to equal 11. Okay, so here we get 2 answers. I'm going to write them up here for our reference so we can do our check. So y equals 6 and y equals 11. Those were the 2 answers that we got, okay? So now let's go back and check both of those answers because we need to see if they both do indeed work for this equation, all right? And I'm going to erase everything so that we can just check it all in one foul swoop. So we'll check the 6 on one side and the 11 on the other, all right? So let's start with y equals 6. Let's check that answer first. Okay. That would mean that we had the square root. I'm just going to put 6 in where y is. 6 minus 2 is equal to 8 minus 6. Okay. Well, 6 minus 2 is 4. So that leaves us the square root of 4 equals 8 minus 6. The square root of 4, we're just concerned with principal square roots, remember, is 2. So we're just taking the positive square root there, and 8 minus 4 is indeed, whoops, excuse me, 8 minus 6 is indeed 2, okay? So that one checks. 2 does equal 2. All right, well, so far so good. Let's check y minus 11 now, okay? So now wherever we see y, we're going to plug in 11. So this becomes a square root of 11 minus 2. Equaling 8 minus 11, okay? The square root of, 11 minus 2 is 9. So we want the square root of 9 equals 8 minus 11. Square root of 9 is what? 3. We're just taking principal square roots. 8 minus 11 is what, you guys? Negative 3. 3 does not equal negative 3. So 11 is not a solution, so we now need to get rid of it. So there's only one solution here, and that's y equals 6, okay? So that just goes to show you why it is so important to check your solutions when you are solving radical equations, all right? So key things to remember, you guys, when you're solving radical equations, you want to make sure that you get the radical on one side, everything else on the other, okay? And then you raise to the index power. Always, always, always check your solutions, all right? Good luck. Let me know if you have any questions.